Welcome back, everyone, for another deep dive. This time we're taking a look at the world of language models. AI and all that. But we're not just talking about any language models. We're talking about models that can really solve some complex problems. And it's all thanks to this super interesting new research paper I found. It all revolves around this model called S1. And it's built to handle this like complex reasoning.
Yeah, the really fascinating thing about S1 is how they actually went about creating it. They took this pre-existing model called Quen 2.532D Instruct, and they fine-tuned it. It's like giving this, star athlete like even more specialized coaching to really like push their performance even further.
So they didn't like build S1 completely from scratch. They basically gave an existing model this brain boost.
Oh.
What was this boost all about?
Well, the heart of it is this concept called test time scaling. So you might think, okay, like bigger models are always better. But this paper, it makes the case that it's more about giving these models the time and the resources they need to really think through a problem.
That's pretty interesting. So instead of just feeding the model a bunch of info and expecting like an instant answer, we're giving it the space to like ponder. Is that kind of what test time scaling is all about?
Exactly. And there are two like main approaches to test time scaling, sequential and parallel. So sequential scaling, you can kind of think of it like as a step-by-step process, kind of like, I don't know, solving a puzzle or something. Each move, it depends on the previous one, and you gradually build toward the solution.
Yeah, that makes a lot of sense, especially for those like super complicated problems. What about parallel scaling? How does that work?
So imagine you've got a team of experts, right? And they're all tackling the same problem, but they're doing it independently. And then they all come together and like combine their insights to reach a solution. That's essentially parallel scaling in a nutshell. But for S1, these researchers, they really honed in on this sequential scaling, kind of like mirroring how us humans tend to solve those complex problems.
Oh, yeah. We don't just immediately jump to conclusions, most of the time anyway. We got to think things through step by step. But how did they teach S1 to be such a good problem solver? Was it just like feed it a ton of data?
Well, they created this really specific training data set for it. They called it S1K. It had 1,000 carefully chosen problems and detailed reasoning traces for each of them. It was really about, quality over quantity.
Wait, only 1,000 problems? That seems kind of surprising. You'd think like a super powerful AI would need way more examples to learn from. Is that normal?
That's what's so remarkable about this whole thing. They actually call it sample efficiency. So instead of just drowning the model in a sea of data, they focused on creating this lean, mean problem-solving machine.
Okay, I'm really liking this less is more approach. Can you tell me a little bit more about this special data set? What kind of problems are we talking about here?
Oh, think like challenging math problems,
Yeah.
like the kind you might find on a, Stanford statistics PhD qualifying exam or something, or like those brain teasers that they use in those super intense, like quantitative trading interviews.
Hmm.
They really wanted to push S1's reasoning abilities to the absolute limit.
Yeah, so no messing around with the easy stuff. That makes sense. You got to aim high if you're looking for that high-level problem solving, right? But how do you even know if the problems are actually hard enough for an AI? What's the benchmark?
Well, they use these two other language models, Quen 2.57b Instruct and Quen 2.532b Instruct, to filter out any of the problems that were too easy. If both of these models could solve a problem, it was out. Only the really tough nuts to crack made it into this S1K dataset.
It's like a training montage for AI, where they just keep raising the bar to force S1 to get better. But it wasn't just math problems, right?
Oh, absolutely not. They included competition-level problems, like from the AB, that's the American Invitational Mathematics Examination, and Math 500, which is like a benchmark of these competition math problems. And they didn't stop there. They added Olympiad problems from all sorts of subjects, like astronomy, biology, chemistry, physics, even some PhD-level science questions from GPQA Diamond.
Wow, they really threw everything they could at it. So S1 is like the decathlon champion of the problem-solving world. So they've got this incredible model and this super efficient data set. How do they even test it? Do they just like throw a bunch of problems at it and see what happens?
Not quite. They use these specific techniques, especially during testing. One of the most interesting ones is this method called budget forcing.
Budget forcing, I've never heard of that. What is that all about?
Imagine you're giving the model a time limit, but there's a twist. It basically prevents S1 from ending its thinking process too early. It's like saying to it, hey, hold on, don't give up just yet. Keep working on it.
Oh, I see. So it's like giving S1 that extra push to really consider all of the possible solutions before settling on the first one it thinks of.
Precisely. It really encourages it to dig deeper into the problem before arriving at an answer.
I really like that. Quality over speed. Let the AI think. Did it work? Was S1 able to solve those super challenging problems?
The results were pretty impressive, to say the least. They tested S1 on 3 different benchmarks, AME24, MAT 500, and GPQA Diamond. And it did incredibly well. It even managed to outperform some of these closed-source models out there.
Wow, so giving the model that extra thinking time made a real difference, huh? I'm really curious to see this in action. Are there any specific examples in the paper that really show us how S1 actually solves a problem, step by step?
Oh, absolutely. The appendix is full of them. It shows you the problem, the reasoning that S1 used, and the solution it came up with.
Like we're peeking right into the AI's brain. What kind of examples did they include?
Well, there's this one really tricky math problem from those Stanford statistics qualifying exams. And you can actually see how S1 breaks it down, how it applies all these different statistical concepts and formulas, and then how it finally arrives at the right answer.
That's really something else. What else is in there?
There's also this super interesting brain teaser. It's from this thing called the S1 Teasers Dataset, and it requires a lot of creative thinking and logical deduction. But the way S1 approaches it is it's really quite elegant. You can actually follow along as it considers these different possibilities and then eliminates the wrong paths until it hits on the solution.
So it's not just about brute force calculation. S1 is showing us that it can actually think strategically. What else did they highlight?
Well, there are also those astronomy problems from Olympic Arena, the ones they designed for, like the top students.
Yeah.
S1 can actually hold its own against those whiz kids.
Yeah.
It tackles these complicated astronomical concepts using all this physics and mathematical reasoning, and it gets to the right answer.
That's incredible. But I'm still hung up on the fact that they were able to do all this with only 1,000 training examples. That seems like such a small amount of data for such a powerful AI.
That's what's so amazing about it. And the researchers, they actually have some interesting theories about why S1 is so sample efficient. They think it might be because S1 was actually built on a model that had already been exposed to this massive amount of data. During its pre-training phase. It's like S1 already had this base of knowledge to work with.
So the training with the S1K data set was more like a refresher course, just reminding S1 of what it already knew.
Exactly. Like sometimes a little nudge in the right direction can unlock all this incredible potential, even in artificial intelligence. It makes you wonder if maybe we, as humans, underestimate the power of reminding ourselves of what we already know, too.
That's a really interesting thought. So test time scaling seems like it could be a real game changer in this whole AI world. But I'm wondering if there are any limitations to this approach. Can you just keep giving a model more and more time to think and it'll just keep getting better and better?
That's a great question. And it's actually something the researchers looked into in the paper. While this budget forcing is super effective, it does seem to have a limit. It's kind of like when we try to force ourselves to think about a problem for too long, we end up hitting a wall, and our thinking isn't as effective anymore.
Right, that point of diminishing returns. Even with AI.
Exactly. So the researchers, they wanted to see what would happen if they combined sequential scaling with some parallel methods.
Oh, yeah. You mentioned those parallel methods before. Can you remind me how they work?
Of course. So there's majority voting, which is like taking a poll of experts and going with whatever the most common answer is. Then you've got tree search, which is a bit more complicated. It's about exploring different paths to the solution and then evaluating which one seems most likely to be correct.
So instead of just one AI working through the problem step by step, they create a whole team of AIs to look at it from all sides.
That's the idea. And the paper suggests that these parallel methods could actually push performance even further, maybe even beyond what's possible with just sequential scaling.
This is mind-blowing. We're talking about a whole new level of AI problem solving here. But before we go too far down the rabbit hole, I think we should take a step back and think about what this all means.
I totally agree. We've seen how this new approach can lead to some pretty incredible results. But what are the bigger implications? What does this tell us about, like, the very nature of intelligence itself, both artificial and human?
That's a great point. We'll be back after a quick break to dive into those questions and a whole lot more. Welcome back to our deep dive into this fascinating world of S1 and test time scaling. We've seen how giving language models more time to think can actually lead to some impressive problem-solving abilities. But, like we were talking about before, there are some bigger questions here.
Absolutely. We can't just focus on all these technical achievements without thinking about what it all means, Like, if slowing down this thinking process unlocks this level of performance, what does that tell us about intelligence itself? Is speed always the best way to measure intelligence?
It really makes you think. I mean, we always connect intelligence with being quick, like fast thinking and those instant answers. But what if real intelligence is knowing when to slow down, knowing when to take your time and really think things through?
Yeah, it's a whole different way of looking at things. And the success of S1 is really showing us that giving these AI systems the space to explore those solutions, to really engage in that thinking process, well, it's super valuable. It challenges that view we've always had of AI as this like lightning fast calculator.
It's like we're moving away from AI as this purely computational process and moving towards this model that's like more human, that includes things like reflection and critical thinking.
Yeah, that's a great point. And it brings up these questions about how we design these systems.
Exactly.
Like maybe instead of just feeding them tons and tons of data, we should be creating these environments that help them really think strategically.
Environments that reward them for taking their time and really exploring.
Right.
Imagine if AI didn't just give us these answers, but like walked us through how it got there,
Oh, absolutely.
showing us all the steps it took to solve the problem.
That would be incredible, not just for solving problems, but for education too, even scientific research.
Yeah.
Imagine AI working with scientists, helping them uncover new knowledge and tackle those big challenges.
This is amazing. But as with any powerful technology, we need to be careful, right?
Absolutely. Responsible development is crucial. We have to make sure that these systems are used ethically.
What do you mean?
Well, one concern is that these systems could be misused, like to spread false information
Right.
or to manipulate people.
That's definitely a scary thought.
Yeah. And that's why transparency and accountability are so important.
Yeah.
We need to understand how these systems work.
So that we can make sure they're being used the right way.
Exactly.
What about the impact on jobs? As these AI systems get more sophisticated, they might be able to do jobs that humans used to do.
That's a real concern.
What if they cause job losses?
It's something we need to be prepared for.
We need to be proactive.
Absolutely. Investing in education and training so people are ready for these new jobs that will require creativity and critical thinking.
The jobs of the future.
Exactly.
Jobs where people and AI work together.
Yeah, it's not about being afraid of AI. It's about using it responsibly and making sure it benefits everyone.
I think that's a great point. It's been so insightful talking about all of this. It's clear that this test time scaling and these models like S1 are going to change AI.
I think so too.
But we need to be smart about it,
Absolutely.
aware of both the opportunities and the challenges.
I agree.
It's all about shaping this new world of AI in a way that's good for all of us.
I like that.
You mentioned earlier that AI might be able to develop some kind of intuition.
Oh, yeah. The researchers noticed that S1 could sometimes get to the right answer, even if the steps it took weren't totally accurate. It's really interesting, isn't it? It challenges how we think AI should work.
So even though we build these systems, we don't always completely understand them.
That's right.
It's kind of exciting and scary at the same time.
It's the nature of science, I think. We're always pushing the boundaries of knowledge, and sometimes we find things that challenge what we thought we knew.
It's like exploring a whole new world, and we don't know what we'll find.
That's what makes it so exciting.
This deep dive has been a great reminder of that. I'm sure our listeners are ready to hear more. So let's move on to the final part of our discussion. We'll be exploring some of the most interesting questions that this research has brought up. Welcome back to the deep dive. We've been talking about S1 and this whole new world of AI problem solving.
It's been a wild ride, hasn't it?
It really has. And one thing that stuck with me is how this research really makes us question what intelligence even is.
Yeah, it's like we're building these amazing systems that can solve these super complex problems, but we're still trying to wrap our heads around how they're doing it.
Exactly. And that leads to some really deep questions. What does it even mean for an AI to think? Is it just a bunch of calculations, or is there something more going on?
I think that's a really good question. And remember how we were talking about S1 getting the right answer, even when the steps it took weren't quite right?
Yeah, that was a mind bender.
It really challenges our whole idea of how AI should work. We tend to think of machines as following these strict rules and logic, but maybe there's room for something like intuition or a different kind of reasoning.
It's like S1 is tapping into some other kind of intelligence that we don't fully understand yet.
I think that's a really interesting way to put it. It suggests that there might be more than one way to get to the right answer.
Like AI could be solving problems in ways that we haven't even thought of.
Exactly. It's exciting, but also a little bit humbling. We're creating these powerful tools, but we're also realizing that we don't have all the answers.
And that's what makes this whole field so fascinating, right? It's a constant journey of exploration and discovery.
Absolutely. We're pushing the boundaries of what's possible.
Yeah.
And in doing so, we're also learning more about what intelligence itself really means.
So if we're still figuring all of this out about AI, how can we make sure we're developing these systems in a responsible way?
That's the big question, isn't it? It's not enough to just focus on how well they perform. We have to consider the ethical side of things too.
What do you mean by that?
Well, one thing we need to be really careful about is bias. AI systems are trained on data, and if that data reflects our own biases, then the AI can actually end up amplifying those biases.
Oh, I see. Like, if the data mostly shows men in leadership positions, then the AI might be less likely to recommend a woman for a leadership role.
Exactly. So we need to be super careful about the data we use to train these systems.
And what about the impact of AI on, society in general?
That's another important thing to think about. As AI gets more advanced, it's going to change a lot of things. Jobs, healthcare, even our personal relationships.
So it's not just about the technology itself, but how we use it and how it fits into our lives.
Exactly. We need to be having these open and honest conversations about the good and the bad that AI can bring, and we need to work together to make sure it's used for good.
Well, this whole conversation has been incredibly eye-opening. It seems like this test time scaling and models like S1 are opening up all these amazing possibilities.
Yeah, it's pretty mind-blowing.
But we need to be thoughtful and responsible as we move forward with it.
I couldn't agree more. We're at a really crucial point in the development of AI, and the decisions we make now are going to have a huge impact on the future.
So, what are the key takeaways you'd want our listeners to remember?
Well, first off, AI is changing fast, and there's still so much to discover. And second, we need to approach it with both excitement and caution. We need to be excited about what it can do, but also really careful about the potential risks.
And I think this whole discussion has shown us that intelligence is a lot more complicated than we might have thought. And there's still a lot to learn, both about AI and our own intelligence.
That's a great way to put it. The quest to understand intelligence is far from over, and I can't wait to see where it takes us.
Me too. Well, that wraps up our deep dive into the world of S1 and test time scaling. Huge thanks to you for sharing your expertise with us.
It's been a pleasure.
And of course, thanks to all of you for listening. If you want to learn more about this, check out the show notes for links to the research paper and other resources. And until next time, keep on exploring and keep asking questions.